In this lesson, I'm going to show you how to use Newton's second law to solve a problem. The question is, a crate having a mass of 75 kilograms is pushed with a force of 225 newtons across a very smooth floor. And we're going to ignore friction this time. The question is, what is the acceleration of the box? I'm going to show you the steps taken in solving such a problem. So step one, we're going to draw a free body diagram. And I'm going to list all the forces that act on it. And the first force would be the force of gravity pulling the object down. Since it's on a surface, we know that there is a normal force pushing the object up to preventing the up-down motion of the object. These two are equal to one another. And we're told that we're pushing with a force. So let's make the force push to the right, Fp. That's step one, draw the free body diagram. Step two, list the given information. List everything you know. And always list A, F, M in this order. So we do solve this problem in a systematic fashion. Question is, what is the acceleration? So there we have A, question mark. We're told that Fp is equal to 225 newtons. And we're told that the mass is 75 kilograms. So step two is listing all the given information. Step three, we're going to identify what the net force is. So the net force would be the sum of the forces in a particular direction. Since we're talking about horizontal, in this case, we see that there's only one horizontal force. So this is very relatively simple. F net is just equal to the push force. Step four, I want you to list I want you to find a formula that you can use to solve the problem. And here are our choices. It's the same formula, but this is written in three different ways. So we're going to use the first version of it. A is equal to F net divided by M. So step four, you're listing the equation. Step five, this is where we actually solve the problem. So I'm going to replace F net with what F net is equal to. So A is equal to Fp divided by M. And now I'm going to plug in the information into this formula. So A is equal to Fp, which is 225, divided by M, which is 75, and use my calculator. 25 divided by 75 is going to be equal to 3. And since it's his acceleration, I know it's 3 meters per second squared, because that's the unit for acceleration. So now I want you to stop, rewind, and list the steps. So that way you can follow them next time. So pause the video, stop, rewind, and list. Question two, how much force is needed to push a 75 kilogram crate across a very smooth surface? Again, we're going to ignore friction, and we're going to have an acceleration of 5 meters per second squared. So step one, we draw a free body diagram. We have force of gravity pulling down. We have a normal force going up. And we have Fp pulling the object to the right. Again, no friction. So this happens to be the same free body diagram as question one. So now we're going to list the given information, A, Fp, and M. This time we're told that the acceleration is 5 meters per second squared. We don't know what the force is, and the mass is 75 kilograms. We want to list the net force, and that's equal to Fp. And then we want to write down the formula that we need, and that's going to be F net is equal to MA, and in this case F net is just FP, and FP is equal to 75, that's the mass, times the acceleration, which is 5. So FP is equal to 75 times 5, which is equal to 375, and the units for force is newtons. In the next problem, we're going to be solving the problem using a rough surface. So we're not going to be ignoring friction. So how much force is needed to push a crate across a rough surface with an acceleration of 5 meters per second squared? In this case, the force of friction equals 75. So the free body diagram, we have the force of gravity down. We have a normal force going up. We're pushing to the right. And friction opposes the motion, so it's acting in the opposite direction, force of friction, like that. So we now have an additional force in our free body diagram. So I have A. This is 5 meters per second squared. FP, I don't know that. I have another force, so I'm going to list A, forces, M. So this is FF, and that's 65 newtons. But that's in a negative direction. 65 newtons in the negative direction because it's opposing. And then I have M, which is 75 kilograms. So that's the given information. So now I want to do F net. And since I have two forces right here, I have FP, and then I have minus FF. It's in the opposite direction. We said that. We pointed that out over here. So now we write the formula. F net is equal to MA. F net is equal to FP minus FF. We've just substituted that. And that's equal to MA. FP, I don't know. Minus 65 is equal to 75 times 5. Look to see where I got these numbers from. FF is 75 newtons, and it's in a negative direction. This is 75 kilograms, and the acceleration is 5. So FP minus 65 is equal to 75 times 5, which is 375. So now I have to take this 65 here. I need to add 65 and add 65. And FP is going to be equal to 440 newtons. Now this answer right here, more force is required due to friction. So not only do we have to pull this object to the right, but we also have to counter the friction.